Welcome to our conics lesson, or the conic form of the quadratic. So we've already talked about the standard form of the quadratic and the parent function or vertex form of the quadratic. There is the factored or intercept form of the quadratic. Now we've got the conic form. The conic form comes from cutting a cone vertically. So if I cut the cone vertically, notice there's this wonderful blue shape here that forms a nice little parabola. We have an equation that defines that shape. And that equation is referred to as the conic form of the parabola. So in my conic form, the k value is moved over, so it almost looks like the vertex form, really, really close to the vertex form, but k is over here next to the y. Okay, h is still inside with the x, so that's the same. But now you've got this 4p thing. That 4p thing is just like your a. Okay, this is essentially my stretch or compress. It's telling me how wide my parabola is. So let's look at similarities, right? H and K, well, that's where my vertex is at. That's easy enough. Only this time we have to change both the signs. You got to change the sign for H and for K. Not a big deal. We can handle that. Now there's two new things in our wonderful parabola. One is the directrix. The directrix is a line directly behind, and it is basically an asymptote. It says the parabola is going to move away from this, not towards it. The focus is where I'm headed. Just like when you're driving. You're driving forward, car's in forward, guess what? You're going to go forward. That's your focus. You're not going to go in reverse. So the focus is where I'm headed. So we have our vertex, our focus, and our directrix. Now we have these two little points on the outside. I'm going to get to those in a minute. The cool part about the relationship here is that the vertex is a distance called p away from the directrix. Aha, that's where my p in my equation comes from. Okay, and so p is that distance. Okay, p is also the distance from the vertex to the focus. So it's equal distant away from the focus and the directrix. Now the even cooler part is that if I look right at the focus, and if the focus were a person and they were to stretch their arms out and go out to the edge of the parabola, that entire width, which is called my focal width, okay, is a distance of 4p. Well, that means that half of it is 2p and the other half is 2p. Okay, easy enough. So we're labeling our wonderful diagram out here from our foldable. Now these two little endpoints, I call them endpoints. They're actually EOLRs. Just remember endpoint. EOLR is one of those long Latin things, and you don't need to worry about it. Just call them endpoints. But those are the endpoints. Those are points that we're going to go through, and that's where our focal width is defined. So we're going to do two examples. This first example, we're going to get the graph. So I'm giving you the graph, and you're going to find all the associated properties with that graph. There's one thing I forgot, and I just realized it. The line cutting through the middle. You guys remember it. That's the axis of symmetry. It cuts my parabola in half. Okay? So now, let's go to example 1. What have we got here? Which way does it open? Well, that's easy enough, right? We just look at the picture. It opens up, the arrows are pointing up, everybody's happy. It's like a smiley face. My vertex, all right. Vertex, that point in the center, where is it at? Well, the x is at 3, y is at -2. So 3, -2, that's my vertex. Happy day, we found the vertex. Axis of symmetry always goes through the vertex. It's cutting through the x-axis, so it's x equals, and remember it's going to be the same value as h. So it's also going to be a +3. Now we need to find the focus. In order to find the focus, we have to find p. Remember, p is that distance between the vertex and the directrix. So this is my directrix down here. My dashed line is my directrix. So let's go ahead and write him down. Okay, directrix is what? It's at y equals, because it's cutting through the y-axis, and we got count down -1, 2, 3, 4, 5. -5. Easy enough. -5 for my directrix. But my directrix isn't 5 away from my vertex. How far away is it from my vertex? Let's find that p-value. I count and it's 3. It's 3 away. Okay, so p is 3. So now I'm going to go 3 in the opposite direction from my vertex, and that finds my focus. Okay, so my focus is where? My focus is at the point 3, comma, +1. Awesomeness. Okay, so I found my vertex, axis of symmetry, focus, P, and directrix. So all I need to do is find my equation. Well, let's just write the template equation. I know I'm going to have y minus a number equals 1 over whatever 4p is, and then in parentheses x minus a number squared. Okay, so I start with plugging in my h and my k. So h goes with the x, so the 3 goes inside with the x, and the positive becomes a negative. Easy enough. The k goes with the y, so -2 goes with the y, and a negative multiply to give me a positive. So it becomes y plus 2. Now we got to deal with that tricky p. Okay, so remember the focal width is 4p. That's what goes down here underneath that 1. Okay, so I could just multiply p times 4, and that gives me 12. So in my equation, I'm going to have 12 down there. So the whole point of finding the information from the graph was to be able to write the equation. Now let's do the opposite. Okay, now I have the equation, I need to find the properties and draw the graph. So the first thing I notice is my h and my k. Remember, I have to change the signs for both. So +2 becomes -2, -4 becomes +4. So I go -2 on the x, up 4 on the y. This is my vertex. Now I need to find p. Well, 4p equals to that 8 in the denominator. Well, we solve for p, right? Oh, that's easy. We're just going to divide both sides by 4, and I get p equals 2. Aha, but wait, there's a trick. There's a negative. Okay, what does the negative mean? If I'm doing a negative in front, yes, you got it. It's going to face down. So my parabola is going to be a frowny face. So from my vertex, I'm going to go the distance of p, which is 2, down. Let me do that in the other color so I'm consistent. Okay, so my focus is 2 down. What point is that focus at? It's at -2, 2. Okay, so where would my directrix be? Well, my directrix would be in the opposite direction, the same distance of 2, so it would go 2 up. Okay, so my directrix is at y equals, and it's 2 up from the 4, so that is at 6. Okay, so this is my directrix. Now let's go in and find our wonderful endpoint. So I got to go half my focal width, or twice p. So if p is 2, then I'm going to go a distance of 4 out from the focus. So 1, 2, 3, 4. There's one endpoint on the right. 1, 2, 3, 4. There's the second endpoint on the left. Now I can draw my parabola from my vertex down through my endpoints. So if the vertex is the body of a person, the parabola is the arms, and the arms are opened that focal width. This concludes our explanation on conics.